Hello friends, today we will discuss about air quality index. Before that we have gone through about air quality monitoring status across India and what is the significance of air quality monitoring. So, there are various uses of air quality data which we collect through air quality monitoring, and one of them is generating air quality index. So, from the name itself it is revealed like index, it is some figure, okay, some values. So, these are the values which are used for various purposes for air quality management. So, today we will discuss about this air quality index and its objectives, its applications, how air quality monitoring and AQI are related to each other, what are the mathematical relationships or formulations of air quality index, and then there are certain like ambiguity or eclipsing, those kind of issues are there, how to deal with that related to the data. Then the methods, various methods are available for calculating air quality indices. So, which is more important, and in Indian context which kind of air quality index is more popular or we use. Then there are issues when we calculate the air quality index, then before that we also calculate some sub index values, because after combining all sub indices then we calculate the air quality index. So, before that what is the calculation purpose of sub indices and on what breakpoints they are based upon. So, what are the computations methods of those. Then we will see here health impacts related to different ranges of air quality index, right. Then applications means how do we apply those air quality indices for air quality management in different cities or countries, and after that we will conclude. So, when we go about air quality index, so basically this is nothing but a kind of thing which define a relationship, a figure, a value which defines an overall scheme that transform the weighted values of individual air pollution concentrations, different air pollutants like SO2, PM10, PM2.5, all those into a single number. So, we first calculate the different pollutants concentrations, okay, and their weighted average or weighted value depending upon their health impacts, and then we combine them. So, then air quality index is basically kind of the communication purpose, primarily a number which starts from 0 to certain high level, like in India we go for 0 to 500. In other cases it could be like one method is there from Tiwari and Ari that gives AQI range 0 to 100 plus. Then other method is there which gives 0 to 125 plus, another one is 175 plus, and the CPCB central pollution control method which we extensively use in India, that is 0 to 500, and methodology is similar to US EPA methodology basically. So, we can say that this air quality index is commonly used to report the level of severity of air pollution to the public, means at any location, at any place, how much intensity or severity or loading of the pollution is there. So, that is reflected by air quality index. Low value means cleaner, very high value means polluted region, okay. Higher number, the greater the health risk associated with the air quality. So, how to means go for this, what are different objectives, what are different applications. So, basically to adopt or develop this one index which is AQI, it is based on national ambient air quality standards and health risk assessments, monitoring program which are like representative for different kind of pollutants in and around a location, okay. So, those data interpretation is there, and this particular range can be coded into different color schemes which is easily to understood by the public, general public, because scientific and engineering approach may be quite complex in terms of values, equations, etc., but general public wants to know whether it is good, bad, moderate, severe, risky, all those dangerous, hazardous, those kind of things. So, to go for those kind of qualitative interpretation, we should have certain quantitative approach also. So, this quantitative approach is basically air quality index related values which give certain range. According to the range we can announce that this is good or bad or poor or moderate, satisfactory, something like that. Then in overall sense we can say that there are broadly 6 objectives which are served by the AQI, like it is used for resource allocation, it can be used for trend analysis or ranking of locations in terms of polluted or cleaner one, okay. Then informing the public about the air quality, right. Then enforcement of certain standards, whether they are being exceeded or they are being honored or met. Then scientific research, because whenever you are coming up with certain new research, new methodology, then also air quality index can give you new approaches to look into that, okay. So when we go about these 6 objectives, basically like resource allocation, as you know, because we have that is limited resources, whether it is funding, etc. We want to solve certain problem. So air quality index can give you priority list. Some location is highly polluted, then better we invest some resources there to clean it first, then we can go less polluted areas, something like that. So evaluation of trade offs it helps in, right. Then trend analysis, because over the years or over the months we can have different values of the air quality index. So that also gives certain trend, whether it is increasing or decreasing. So those kind of trends can give us some information, whether whatever some measures we are taking to clean air, to improve the air quality, whether it is working or not, okay, those kind of things. So trend analysis can give that kind of information. Then ranking of locations, as I said, you can easily rank with the this is highly polluted, this is less polluted, okay. So ranking of different cities with the air quality index you can go for, or ranking of different locations you can go for, right. Then public information, it is very easy, because easily understand that range, whether it is high value then it is highly polluted, less value less polluted. And you can also link it with some color schemes, which can be through website or through boards, etc. okay, digital boards, you can give that kind of information which is visible to public and they can understand it easily. Enforcement of standards, because there are certain standards, and if they are exceeded by high concentration, ambient air concentration, then this air quality index will be higher. So we can easily link, means if some standards are being met or being exceeded, air quality index can give us information. So we can think in a very easy and very fast way to see whether standards are being met or not, right. Then scientific research, like it can give new information for research purposes related to air quality data, it can give new insights for conducting studies on some environmental phenomena which could be responsible for poor AQI or something like that. Suddenly suppose you get AQI at a particular location very severe, so then you want to study what is the reason, whether some local source is responsible or some transportation of from upwind direction some pollution has come, so that you can do research and you can link the regions of that poor air quality, right. Then we can address those regions. Well, when we go for like what is the role of air quality monitoring in generating AQI or air quality index. So basically online monitoring and manual monitoring goes on in entire country, and the online monitoring network, which is automated way of air quality monitoring, this gives continuous monitoring, okay, of different pollutants. So this is the real time AQI computation is possible with those data, but in case of manual monitoring there is a data gap, okay, because intermittent monitoring is there, you have to change, you have to analyze in the lab. So real time concentration values are not available for those purpose. So this is not suitable for AQI calculation for quick interpretation, right. But historical AQIs on weekly basis for data interpretation is possible, means just to see some kind of relationship. But if you want to go real time AQI to public, that every day or some forecasting something, then only this online monitoring network is really helpful. Well, then how to calculate this air quality index? So these are two step calculation steps. Like first of all we go for each pollutant like X1, X2, X3, X4, Xn. Okay. So we know that for each pollutant we can calculate one index. okay, like I1, I2, something like that. This is the function of the concentration of that pollutant X1, X2, something like that, right. Then we developed these indices, sub indices I1, I2, In for each pollutant, okay. That will give us whether this pollutant is highly polluting that particular place, or it is okay, it is satisfactory within the range of acceptable limits. Then we combine all these sub indices, we aggregate. So, the combination of all these indices, when we integrate or aggregate, then we come up with single index value, okay, I, that is the summation or multiplication or integration you can call of those individual indices depending upon different pollutants, right. So, that is the basically aggregation single value of the air quality index, which incorporates or which take into account all sub indices related to different pollutants, right. So, this is the way, like sub indices we form I1, I2, I3 for different variables, these are nothing but concentration of pollutants, right. Then this is the function, so we get values, and then we go for this kind of summation, like this equation is there. So, for each kind of pollutant you can calculate I, and then you have single value of summation or integration of aggregation of all those values. And here this particular formula which is used in India also basically. So, you can see like this ILO, this is AQI value corresponding to BLO, and BLO is nothing but breakpoint concentration lower or equal to the given concentration, which is available concentration, monitored concentration. BHI, breakpoint concentration higher or equal to given concentration, and these are related to like IHI, AQI value corresponding to BHI, ILO, AQI, that is air quality index value corresponding to BLO, and CP is the pollutant concentration basically. So, you put those values and you get this index II, okay. Then you go for different pollutants and then you summation occurs, then you can get the single value. So, there is one example like for PM10, let us assume that concentration is 85 microgram per cubic meter and BHI is 100 and this BLO is 50 and IHI is 100, ILO is 50. So, the calculation becomes very easy and you get this value, you put those values 150, 85, this is 85 and 50, this is 50. Okay. So, you get the 85, this sub index of this pollutant P is 85. Similarly, you can calculate for different pollutants and then you can aggregate them. So, this air quality index aggregation is there for all I1, I2, all IN. Okay. So, aggregation is possible and you can get the single value, like summation may be there, but there are other ways like weighted additive form can be there. So, this is like for each pollutant weighting is there, weight means for depending upon their intensity, depending upon their health impacts, etc. So, you can go for that number of pollutants is N, Wi weightage for the pollutant I, okay, and II is sub index for the pollutant I, that kind of thing is there. So, you can go for aggregation in the fashion of weighted additive form. Other ways are there like for example, root sum power non-linear aggregation form. So, this is summation IIP. So, integration is there and 1 by P. So, this kind of P is positive real number greater than 1. So, that you can have from other sources. Similarly, root mean square form is also there for aggregation. So, this is the way for root mean square, okay. You get square root of this all the I values square of summation and then square root. Minimum or maximum operator will be there I1, I2. So, you can get minimum and maximum values. So, different ways are there for aggregation purpose. Then when we go for these kind of numbers or indices, there are issues like eclipsing or ambiguity, like eclipsing eclipsing is something when an air pollution index does not indicate poor air quality, even though concentration of one or more pollutants may be reaching unacceptable high levels, okay, high values. So, that is the eclipsing, means polluted environment is there, but index is saying that it is fine, no problem. Okay. So, that kind of error may be there. So, that is kind of underestimation, means single value AQI is coming underestimated, although the parts of it, certain pollutants are having poor air quality range, but when we are going kind of aggregation, then it erroneously comes out that it is fine, that means underestimation is there. So, that is eclipsing. Ambiguity is there, like when air pollution index gives a false alarm, means there is no individual pollutants are within the range, they are not exceeding those standards, but when we are summing up, we are aggregating, then the value is higher, that means it is overestimating. So, this gives the false alarm. So, that is ambiguity. So, we have to deal with those kind of statistical things, and we should be careful, otherwise even if air is clean, we are giving false alarm to the public, and public is confused. They say that okay, we have been alarmed that we should not go to that particular place where air quality index is poor, but in real sense it is not there. So, those issues we have to deal with. So, in order to remove these kind of error, eclipsing and ambiguity related problems, new indices have been developed. Okay. So, like maximum operator approach is adopted to remove these kind of errors. So, AQI maximum, I1, I2, In, those kind of values are computed, and the health impacts of the combination of pollutants are not known, because synergy is not known, and thus in the health based index sub indices cannot be added or multiplied. So, that is another issue basically. Okay. Well, when we talk about calculation methods, so we can go for different methods, like this method one is from Tiwari and Ali in 1987 they published. So, this is AQI 1 by n summation of 1 to n Ci upon Cs into 100, where Ci upon Cs is small q, and this q is air quality rating of any individual pollutant, and Ci is observed value of that particular parameter, and Cs is standard value of recommended parameter, n is the number of parameters. So, that kind of again integration is there and possible, and for that particular purpose there are range, like if it is below 10, then it is known as very clean. If it is between 10 to 25, then it is known as clean air. If it is 26 to 50, then it is known as fairly clean. 51 to 75 signifies moderately polluted, not very high. 76 to 100 polluted, and more than 100 heavily polluted. So, those kind of difference is there as per the range of those indices values. Second method is like geometric mean of the ratio of concentration of pollutants to the standard value. So, AQI is by anti-log of this 1 by n log q1 log q2 log qn, and where this qn value comes, qn is nothing but Cn upon Cs into 100. So, qn is quality rating, Cn is observed value of that pollutant, and Ch is recommended value of the pollutant, n is number of pollutant considered. Then according to this method, there are again range similar to the earlier one, like below 10 very clean, 10 to 25 clean, 25 to 50 fairly clean, and then there is another range like beyond 100, 100 to 125 heavily polluted, and above 125 severely polluted. So, this kind of next level of pollution it also gives the information about. When third method is there, which is known as pollution index method, and this was used in this Naples city in Italy. So, this is the method, like pollution index is I1 plus I2 upon 2, and sub index Ix V maximum Hx upon VRIF into 100, and the values of I1 I2, these are nothing but sub indices of two most critical pollutants having higher concentrations. So, means there are many pollutants, but select those two highly critical pollutants, right. Then V max, okay, V max Hx, the maximum 1 hour mean value of the critical pollutant, and VRIF maximum 1 hour limit value of the critical pollutant. So, these values are used for calculation purpose of sub indices, and then AQI can be calculated, and according to this like 050 gives the quality indicator, it is optimum. So, no risk for the people. So, you can see 51 to 75 it is good, no risk, 76 to 100 moderate, no risk. Okay. Then 101 to 125, then it is like mediocre, and the numerical index is 4, and this is generally associated with kind of like asthma, chronic bronchitis, cardiopathy, okay, light respiration symptoms and during intense physical activity. So, those kind of things are there within this AQI range of 101 to 125, right. Similarly, there are other values like 126 to 150, okay, not much healthy. There are risk for people with heart diseases, old people, children, okay, and this numerical value is 5 here. 151 to 175 it is unhealthy, okay, and many people feel light adverse symptoms, and weak people may feel the gravest symptoms. Then more than 175 very unhealthy, and the 7 is the numerical index, and this is like very adverse health impacts may be there. It may be very risky to old people, children, and respiratory diseases may be very high in those particular situations. Then method 4, which is also used in India and adopted by CPCB basically, okay, this is linear segmented principle, which is used to calculate the sub indices. In this case you can see this formula, we earlier also have seen this. So, IP equals IHI minus ILO, BHI minus BLO into CP minus BLO plus ILO. Okay, those we have already seen. IP is sub indexed for a given pollutant P concentration. BHI break point concentration for greater or equal to given concentration, that is CP. BLO break point concentration is smaller or equal to given concentration CP. IHI AQI equivalent to BHI, ILO AQI value equivalent to BLO. So, those values we can get from certain studies, like these kind of tables are there. So, where AQI is 050 good, and color scheme is dark green, for that this is minimal impact, means there is no impact you can say. 51 to 100 it is satisfactory, and this is light green color scheme. Then minor breathing discomfort may be there to sensitive people, otherwise normal people will not have any problem. Okay. So, this way you can see AQI goes 0 to 50, 51 to 100, 101 to 200, and ultimately 401 to 500, which is severe, okay, and this affects even healthy people. So, this is very serious, red color is there for that. Okay. Before that dark orange is there, 301 to 400, that is very poor quality. So, according to the range, the quality of air is given some name, the color scheme is given name, and health impacts are associated, which are also tabulated. So, Indian Air Quality Index or IND AQI you can go for short. The overall AQI system is basically like this, we talked: good 0 to 50 dark green, satisfactory 51 to 100, the moderate 101 to 200 yellow, okay. Then this poor to 201 to 300, then very poor. So, you can have these color schemes also, and different pollutants are there, okay, SO2, O3, NO2, all these pollutants their concentrations are included when we calculate the AQI. So, like for example, if we consider CO, carbon monoxide, and we have we know that CO is problematic because it has tendency to get absorbed into the blood, and it reduces the capacity of getting the oxygen into the blood. Okay. So, that is the reason it is dangerous, and you can see its health impacts like mild headache when it is the percentage is less than 20 or so, it goes on increasing, then its impact is also increasing, and unconscious can be there, like if it is 50% or so, and it can also lead to death, in fact, if it is very high concentration in the blood. Okay. So, when we talk about its break points, so you can see the values, and different countries have different values, okay, like AQI category good, break point 1, satisfactory 2, this is for India 8-hour concentration, please note it. In US 8-hour concentration, good, 5, 11, those values are there. China, they have 24-hour concentration, and their categories are like excellent, good, and they have different values, break point concentration like 2, 4. In European Union, this is again 8-hour concentration, and they have different names like very low, low, and ultimately very high. Okay. In China, it is severely polluted. We also have like severe at last, and US considers hazardous. So, different nomenclatures are there depending upon the values of those indices and those break point concentrations values. Okay. Now, if you go for like NO2, okay, like CO, so different values are there for this, like breakpoint 40 for good, satisfactory 80. So, different values are there. Okay. Similarly, for US, China and EU it is given, and similarly PM 2.5 and PM 10, all these tables give those values of their breakpoints as well as their name, whether it is good, bad, something like that. So, ozone related, SO2 related, all these values are there tables, you can go through at leisure and see different values are there for different pollutants, please remember. So, the different sub index will be calculated for each pollutant, then we will aggregate them. Okay. Lead and ammonia also some countries do not consider, but in India we are considering these also, and these are the values good 200 for ammonia, 0.5 lead, because that is heavy metal and very problematic. So, you can see this colored representation of Indian air quality index breakpoint AQI scale 0 to 500. So, PM 10 24 hour, good 0 to 50, PM 2.5 0 to 30, NO2 24 hour 0 to 40. So, different value range is there, okay, these AQI related breakpoints. Then there are health impacts also, because like good means minimal impact, satisfactory it may cause little minor breathing related issues, discomfort to sensitive people. We have seen poor air quality, it can cause breathing discomfort to people for prolonged exposure. Okay. When it is severe, then it is kind of very dangerous when we are exposed to this severe air quality, means highly polluted. Okay. Then what is the application? What is the application? So, application are many, as I briefly discussed initially also. This can give to policy makers a way of quick decision making, okay, in the form of rules and regulations as per the requirement. You might be in these days when winters are there, and in Delhi this poor air quality is becoming very big issue. So, you might have read in newspapers that the judiciary is asking the government that even if you have to do the lockdown, thus reduce this air quality index, it is very high now. Okay. So, what are the different ways which can be implemented? So, these air quality indices help in decision making for these kind of interventions. Like in Beijing in China, on red alert days when AQI falls to very poor or severe category, they go for like they stop school functioning. Even in Delhi, like for few days schools, colleges have been shut down, right, because air quality is very poor. This AQI is giving this range that it is very poor, or kind of up to the severe kind of thing. Then 80% of government owned cars are taken off the roads in Beijing when this red alert is there for severe category of air quality. Okay. Private cars allowed on alternate days, like odd and even we did last time in Delhi, if you recall. At construction sites, excavation and demolition related operations are stopped, because they emit lot of particulate matter, and that contributes to the poor air quality. In winter, it is very problematic because of inversion, etc. In Paris, this AQI related application have been made, like in March 2015, to control the air problem, they made public transport free and removed 50% of the vehicle of the road, those privately owned, so that people can go for public transportation if it is not costing. Then private cars allowed on alternate days, and no diesel cars on the road on the smoky days were allowed. And then this minimizes combustion of high sulfur fuels in industry and curtails industrial operations, right. Similar measures have been implemented in different cities of the US, UK and Mexico. So, similarly, if we go for this demonstration of or example how to calculate when different pollutant related concentrations are available. So, this is one example. You can see calculate the AQI for given air pollutant concentrations, different values are there, like PM 2.5 33 microgram per cubic meter, PM 10 is 63 microgram per cubic meter, ozone is around 49 microgram per cubic meter, NO2 15, SO2 4, CO is 650. So, we use this particular relationship to calculate the individual pollutant related sub indices, and then we will go for its aggregation. So, here you can see for an example for PM 2.5, 33 microgram per cubic meter. Okay. So, where it lies 33 here 31 to 60, okay, within this range. So, 5100 is the basically this range of the AQI, okay, and the 30 will be the minimum, 60 will be the high. So, 60 is BHI and BLO is 30, okay, and 150 is because this range IHI ILO, this 50 is the lowest, this ILO and IHI is 100. So, these values are here. So, you can use concentration is 33, BLO is 30 because the lower concentration value in the range of 60 and 30. Okay. So, you can go for this ILO is 50 again as I said. So, you calculate the 55 this IPM 2.5, this is the sub index of PM 2.5. Similarly, you can go for PM 10 and then NO2, ozone, okay, and then SO2, CO, all different values are there. ISO2 came only 6, CO it came 33, okay. You go for this ozone it came 50, NO2 it came 20. So, different pollutants, different sub indices, okay. Then we go for overall AQI. So, maximum of these, okay. What is the maximum value? We go for IM 2.5, IM 10, IO3, NO2, all those. So, 63 is the maximum value. So, we go for this particular method, the last method where we choose the maximum value, right. Otherwise, you have seen those issues with when we go for these statistical problems like ambiguity etc., that happens when we go for aggregation. So, to avoid that we go for this highest value approach. So, 63 is the satisfactory. Why satisfactory? You can see the overall value, this is 51 to 100 in between this range. So, this is satisfactory. So, that is why we call even overall value is satisfactory, but like ozone, NO2, SO2, CO, all these values fall in good category if you compare individually, right. For example, let me tell you the CO is 33, right. So, 33 is in good 0 to 50 within this range, this is good quality, but overall is satisfactory. Okay. So, individual pollutants may be bad quality or good quality, and overall concept is dependent upon the highest value of a particular index, and then we see in the overall this scheme where does it lie. So, overall it is satisfactory, although individual pollutants it may vary good or satisfactory or something like that. So, that way you can see like particulate matter in the region is high, and in order to improve the air quality, sources of particulate matter emission are to be regulated, because this value is related to PM 10, this 63 is PM 10. Okay. So, those particulate emissions if we can reduce, then this air quality index can improve. Okay. So, in conclusion we can say that air quality index helps in easy understanding of air pollution levels in real time. Okay. It can really help us whether to visit a place or not. If it is air quality poor, then we can refrain from going to that particular place, particularly the sensitive people, old people, those who are already unhealthy, they should not get exposed to the poor air quality. So, air quality index gives quick information about that, right. And higher AQI, we know that it is higher health risk, and AQI can easily be interpreted by common people because it can also be color coded. So, very easy to understand, and it can assist in data interpretation for decision making, whether we should stop private cars, we should stop diesel cars, or depending upon what kind of pollutant is in high concentration. Then different countries have different break point concentrations depending upon their national ambient air quality standards and health risk related issues. Okay. So, they can have different air quality indices also. So, this is all for today related to air quality management through air quality index. Okay. So, this is the larger part is basically air quality management, how to improve the air quality and how to know whether it is polluted or not, and air quality index is very easy and simple and quick way to know whether air quality is good or bad or satisfactory or unsatisfactory, those kind of things. So, this is all for today. Thank you for your kind attention. These are the references you can go through to have more information about air quality index, their calculations, their uses, applications, etc. So, see you in the next lecture. Thank you till then. Thanks a lot.